Hello everyone. So today I will be presenting you something that I made over the last 5 weeks, and it is a custom-made project, something that is called Project Quad. Project Quad is actually a complete local AI document system that allows you to upload the documents to the system, to ask questions about the documents, to visualize embeddings in 3D space, and many other different interesting things. The main thing about the project itself is that it is 100% local and private, and it has zero cloud dependencies. So let's cover what this project is all about. So on the front end we have the Streamlit web UI, we have the plotty for visualization, we have the scikit-learn for dimensionality reduction, and requests which are going through the HTTP client. For the backend we have the fast API, we have our local Qdrant vector database, we have the Ollama local models installed, we have a Docker for containers, and to add a little flavor we have the N8 workflow, which is collecting the tags in the summary. So let's check what's going on in the background itself. So as I mentioned, we have our Qdrant vector database here running. We have an N8 working locally as well. Right here we can see the N8 instance running here in the background. We also have the Ollama model running in the background as well. For containers themselves, we have the Qdrant, as we mentioned here. We have the Gradio, which we will talk about a little bit later. The Nginx, which is the local DNS resolver. The Quad for Streamlit, which we are currently working on, and the fast API. So let's jump into our system and let's see what this baby can do. So first let's check out the health, and the system is reporting that we don't have the Ollama server running. So let's fix that one and let's go back. So in the document section here we can upload the files. As I mentioned previously, we can upload the PDF, doc, or TXT files. And for this purpose we have 3 files which are basically just the sample files picked up randomly. So one of them is actually rules of golf, simplified, so basically it tells something about the game, the match, the clubs, the ball, the player, and so on and so forth. So we'll use that document and we'll embed it in our vector database. So once again, browse the files, rules of golf, and we will enable this NNA auto tagging, which we'll cover in just a few moments. So let's upload the process here, and we can see that our Ollama server has started and it's currently processing the document and uploading it to our vector database. So once this process is completed, the system itself should kick in the N8 auto tagging, which should use the AI to extract the text and the summary. So it's using the document ID, it's firing the N8 in the background, and the process is actually complete. So let's take a quick look here. Let's see if the vector can be visualized. Yeah, so this is our current embedding in our vector database. So let's see what happened in the background in the N8 itself. So once the document was actually embedded and parsed in our database, the app itself is calling the webhook, which is actually starting this trigger in the N8 workflow. So this is just collecting the confirmation from the document uploaded URL. It is calling the fast API for auto tagging, and it's basically using the AI to use the document ID to extract the summary and the text from the document itself. So once that is completed, we can use that metadata and insert it into our document ID / metadata with the put command here. And basically, as I said, we are adding the tags and adding the summary here. So once that is completed, we just respond to the webhook to the process itself, which is informing us later that the process is completed. So behind the scenes, it looks something like this. So we have our last execution here. The webhook has started. We have an AI, as I said, this is the Ollama 3.1 with 8 billion parameters, which is tagging the document itself and it's extracting the summary itself. Once that is completed, we are updating the document metadata, as I said, with the document ID. We are putting into metadata folder with the put command, and we are responding to the webhook, acknowledging that the system has completed the process and the whole document process is now complete. So we can see here all our embedded chunks in our vector database listed here, and we can check the database itself, which now actually contains the documents, and we have the rules of the golf simplified document. Now we have the tags as well, and we have the summary, which is embedded by the NN8. So going back to our document itself, we can use the chat here, and we can ask it any question that we like about the document. So for this purpose, let's go with the Granite 4 and ask it, tell me about the car. So let's see what this will actually give us as a result here. So the Ollama is accessing our vector database and it's searching for the car, and it says the context provided does not include information about the car. It appears to be related to simplified. Basically, it's responding the way we intended it to, so it's just answering the questions related to the document itself. Now, for a quick reference, we'll upload 2 more documents here just for testing purposes. So once again, once we browse the file, we will use a document called the guardrails. This is just a simple document explaining a node in the NN8, and we will use that document here for the reference. So let's upload that one as well. NN8 auto tagging, upload process. So the process was completed, and it's firing the NN8 to add the tags and the summary. And we'll do the same process for the this document here, which is the MikroTik, some setup of the MikroTik. So let's use that one as well. So browse the files, let's go to the MikroTik here, and let's upload the process here. Once again, firing the server, embedding, then the NN8, and once that is completed, we will go to our 3D vector visualization, and let's see how this actually looks. So in this plane they actually look close together, but if we take a closer look, we can see that our embedding for the MikroTik is much closer to the guardrails. So this is what we expected here. So without further ado, let's get into the RAG process and let's see what we can do here. So if we ask the same question about the car, it will give us the same answer here, but let's say tell me about the ball. That's something that was in the document for the golf rules. So once we actually fire up the question, let's see, Ollama is accessing the vector database, and the answer here should be, let's see it here, it actually says based on the provided context rules of golf simplified, the ball is damaged, you cannot fly. Basically it's accessing the document and providing us with a rule from the document itself. In order to do that, the system was actually using these embedded vectors, so we can track those. We can retrieve chunks before re-ranking, which are listed here. Then we have the re-ranking process, so keywords after the re-ranking process are listed here. We can see the final prompt sent to the AI, and we can see other stuff like general metrics, that is tokens which were used, the time and the tokens per second. So after that we have the sources, which are just 5 chunks, because we actually set the KTOP to retrieve 5 chunks, so it's listing which 5 chunks are used here to answer our question about the ball. In order to see what kind of answer the large language model will provide here, we can use the tool here, which was made in Gradio, and it's actually used to test the multiple models here. So once we actually fetch the models here, we can see all the 12 models being listed here, and we can test each model individually. So once we go to the model comparison, we can ask it any question here, but let's use some of the predefined ones, like what is the capital of France and what it's known for. So in order to test the models here, we will use, let's say, Granite 4 with 3 billion, Granite 3 with 8 billion, and let's use the Dolphin here. So let's compare the models. Once again, the process has started here, and it's kicking off once again the Ollama server, which is now testing all 3 models and providing us with the answer itself. So let's see what kind of results we will have once this is completed, and it should be any moment now. So we can see here that the Granite 3.2 with 8 billion was the fastest. It used 96 tokens. The same thing went for Granite here, and the Dolphin actually used 71 tokens, and we can use the model here, the JSON output, to check each one of those models, the Granite itself, other information. So we have the model for Granite 3.2 and for the Dolphin. So we can check the quality of the responses here. One thing that is currently missing here is something that is limited by my graphics card, which is AMD, and we have to have some CUDA drivers here in order to quantize the model further and distill it with the LoRa. And for now, this fine-tuning section is waiting for a new graphics card and will be implemented in the future. So this is it for now. For the whole project itself, we have the complete documentation here. We have the API which was used, how we can actually access the root, to perform the health check, to list the models, something like this. So it will give us the models. We can reset the collection, delete the collection, and basically we can manipulate the document and gather all the different information here. So that's it for this short presentation. I hope you liked it, and if you did, leave a comment or a like, and that will be all for today. Thank you.